So recording has been started. So guys, I have certain sets of questions that I will be asking to you, and I will be also answering in a way like this discussion, this question and answering will be like we are answering like an interview. We'll follow that type, okay? And so without wasting any time, let's start it with the first question. What is that? And the first very question, I don't have that much idea, but I will be asking you, what is NDT, non-destructive testing? Anyone?
Can I start?
Yeah, sure.
NDT techniques are are the techniques where we use the yes. I'm really sorry. Let me start rephrase it again.
Okay.
Um, in NDT methods, like in non-destructive testings or techniques, we use non-destructive techniques in a way to test our RM, that is raw material, in industrial or production line, right? Or in maintenance to check the part that is it healthy or not. Because the another way to go is to crack it open and do chemical tests and various tensile strength tests on it. And the major NDT methods are, first is which I like the most is ultrasonic testing. Second is dye penetration testing. Third is radiographic testing, and fourth is uh, fourth one. Fourth one I forgot. I'm sorry.
Visible testing, magnetic particles.
Yeah, magnetic particle testing, very important one. Yeah.
Magnetic particle testing is same as magnetic crack detector.
Yeah. Yeah.
Okay.
The liquid penetrant.
Okay.
Yeah. That I mentioned, that dye penetration testing.
Okay. So what Pragyan, what you have just mentioned now, magnetic crack detecting, radiographic testing, you have to also explain that. What is this?
Okay. For sure. Let me start with ultrasonic testing, right?
Okay.
In ultrasonic testing, we have three parts: uh, the transducer, the probe, and the display panel. And let me also mention the working principle. Its working principle is on the basis of reflection of mechanical sound waves, right? Uh, it's just like sonar, like we use in submarines, right? And the working is as follows. When we place the probe on our material, it could be any type of material. Like it can be ferromagnetic, non-metal, anything. Uh, then the probe generates high mechanical pitched voices, uh, which travel through the test object and gets reflected back either at the bottom of the test subject, or either at the crack or porosity or any cold set there might be there in the test subject. And when the sound waves return back to the probe, the probe sends the signal. Probe also acts as a transducer in this, where when it absorbs the mechanical sound waves, it converts it into electrical energy, and this electrical energy is shown as a signal for our electrical display. So that it's like an ECG, right? That we have in hospitals. Like we have a graph on the digital screen, and with the mathematical calculation, we can exactly determine the position, the orientation, the size of any crack there might be in the test subject. This is the ultrasonic testing.
All
Now, magnetic particle testing is in which, let me first mention the most important
wait. Anyone else like to explain ultrasonic testing? What is ultrasonic testing? Here, Harvinder, bro. Anyone else? Okay. Pragyan brother, what I got, I don't know much about this ultrasonic testing, but after listening you, what I got, it is like it uses ultrasonic waves and it got some transducer and receiver and display unit, that digital display you were talking about. Their waves get reflected and some kind of signal is provided by transducer. So without breaking up material, ultrasonic wave is used for testing the strength of that material. Isn't something like this? Because you explained
No,
very
it's not.
lengthy.
I'm really sorry. To put it in a precise manner,
Mhm.
there are three parts. First is a probe. The probe, it's like
Stylus. It can be
uh,
called as
uh,
probe. ठीक है? Stylus.
uh, it,
Okay.
it's like stylus, but a little broader,
Hmm.
not like thin like the stylus, right? The stylus and the stylus actually acts as a transducer within itself. But I am mentioning it separately, and which is connected to a digital display. Now, as the probe will generate high pitched, high frequency voice sound waves, the sound waves will travel through the solid subject, right? The sound wave will travel through the test subject. Now, these sound waves will either reflect at the bottom of the test subject where it is touching the ground, right? If there are no discontinuities within it. But if there is a crack in between, like let's say at an height h above the ground, the sound waves will will reflect back from the crack, because sound waves cannot travel through the medium of the crack, that is air. When the medium changes, the sound wave will not refract; it will reflect, and this reflected sound wave is then captured by the transducer. A transducer is a device which converts one form of energy to another. It could be heat energy to electrical energy, mechanical to electrical energy. So here, when it absorbs these sound waves reflected by the crack, it it converts it into an electrical signal. It is a mechanism of diodes in it. So this electrical signal is then passed on to the display unit, right? Because the display unit only responds to electrical signals. Now the display signal, now our digital display will exactly calculate and show us where is the crack, like at how much depth, and what is its length, what is its angle with the surface, like its orientation, is it horizontal, is it vertical, is it at certain angle, like that.
Okay.
And it's the best method with which we can test, because it does not spoil the material like dye penetration testing, and it covers all the materials. Like in magnetic particle testing, we can already use magnetic ferromagnetic substances, and we can not test non-metals with magnetic particle testing, right? So it has certain limitations, but ultrasonic is the testing we can do for all the materials.
Okay. All right. Vito, have you any idea about this technique, this ultrasonic testing method?
Yeah, my idea also is pretty limited as to what he was mentioning regarding the three components. And as you mentioned, how it works, where the moment you have the crack, you have a change in medium.
Hmm.
So instead of going all the way to the bottom, wherever the crack is there, from there it will bounce back. So if you know that, okay, my main probe is kept 5 meters from the ground, but if my reading of the total distance that the sound wave is going and coming is only showing 2 meters, that means somewhere 2 meters from the top there's some kind of obstacle or some crack that is blocking the wave from passing, and then that can be further investigated.
Yeah. Anyone else?
Another one thing in ultrasonic testing, they use couplant between this probe and material. It can be
Karthik, come
grease.
on camera, na. Why you people are not coming on camera other than Avito, because he is using mobile in his
Yeah,
Over to.
wait a minute. Wait a minute. I will be on.
Okay. Vito, what was the pause we made? The hotkey for pause.
So I think, as I recollect, for record we had done plus,
For.
for we had done minus,
Hmm.
and we had done multiplication and divide. So I think,
For multiplication, I think for pause and for pause we have used that multiplication pause and play. Yeah. Now I remember.
yeah,
Okay. Okay. All right. Yeah, Karthik has come. Yes, Karthik, go ahead.
Actually, in ultrasonic testing, you person have left one thing, that is they use coupler in between the probe and the material. That's what I came to say.
Okay. No issues. All right. So we got very much idea. We need to study by ourselves also what actually it is. Thank you guys. Thank you Pragyan for your input and Avito. Now we'll be moving on the testing, that is magnetic crack detector. First tell me, it is same as the magnetic particle inspection?
Yes, it's the same.
Okay. Now anyone explain? Karthik, would you like to explain what is magnetic crack detector?
Sorry, I don't know about a magnetic crack detector. I know magnetic particle testing.
Wow.
I actually don't know what is meant by this crack detector.
Okay. It is same as this. Like what I have little much idea about this is, in which at some concentration we put something on ferromagnetic material, and it will concentrated if there is some kind of crack, is something like this only. I'm so sorry guys, I am not that much very good in this thing. It is like that only, Pragyan?
Yeah, uh, it works on the principle of leakage of magnetic flux.
Okay.
It's like when we use ferromagnetic material for testing, right?
Hmm.
We sprinkle the magnetic particles. That is a scientific way to say it, but an easy way to say it is we sprinkle iron sprinkles around it, around the whole test subject, surface of the test subject. Let me first mention the limitations of this. There are two limitations, I think. First is we can only test ferromagnetic substances. Second is it can only test uh, cracks or any other deformities near the surface of the test subject. Because, uh, uh, and now let me come to the working
Near the surface of what?
or of the test subject. We are testing the material, right?
Right.
So now let me get to the working. We have the following three components: an electromagnet to produce magnetic flux.
Mm.
Second is the test subject on which we have to do the testing,
Mm.
and third is the magnetic particles.
Mm.
So here, when we sprinkle the magnetic particles all over the test subject,
Mm.
and then uh, when switch on the electromagnet,
Mm.
the the cracks on the if there are any cracks on the
Mm.
test subject,
Mm.
there will be flux leakage around the crack,
Mm.
and this flux leakage uh, will attract the magnetic particles around it. So it will in a manner highlight on the surface of the ferromagnetic material
Mm.
where is the crack is and how what is its orientation.
All right. So, magnetic particle inspection, that is magnetic particle testing, uses the principle of electromagnetism. Okay. So, in which what I got you from, in which we use some magnetic particle, we sprinkle on the surface of testing material and apply electromagnetic field, and what happens now, where there is any crack, the magnetic flux that is get concentrated on that portion or get drawn into that discontinuity. That is you what you meant. I got you or not?
Yeah, yeah.
Okay. So, guys, other than Pragyan or Karthik, they are giving us so much, this much enlightenment. So, after that, we will be reading by yourself, but it is really helpful. If anyone having some doubt, they can ask, because after that question, I am very good at that. I will be also discussing, and if you guys can discuss with me at that time, but at this time,
Another one thing,
uh,
yeah, in magnetic particles testing, Pragyan Badar told near surface, and he haven't mentioned much deeper regarding that. Actually, the in magnetic particle testing and penetrant testing, the main difference is in penetrant testing we can find the defects at the top surface. Surface defects only we can find,
mm,
but this magnetic particle testing we can find the defects for little deeper. Deeper cracks only we can find, and apart from that in ultrasonic testing we can find cracks in much deeper spaces also we can find the defect. That's the main difference. That's what Pragyan also came to say, and
okay.
he haven't said that much cleared. I'm just clarifying.
Okay. Making sense, making sense. But ultrasonic testing can be used for any type of material. Magnetic crack detection,
Yeah, definitely.
magnetic particle inspection, that magnetic particle testing is for only ferrous material, and dye penetration
Yeah,
testing for non-ferrous, ferrous materials, ceramics,
yeah,
plastics, anything. Okay, so
yeah,
they
except porous,
accept porous. Okay,
porous materials.
porous material can't be can't be tested by dye penetration test.
Actually, if you think porous type of materials have some pores, and if you put any dye or any things, it will also makes some defect like appearance. So mostly they won't use in the areas of porous materials. They won't use these things. They might go with the ultrasonic testings or radiographic testings.
Oh,
Gyan,
yes.
just first question.
Uh,
So the first question is, if suppose ultrasonic, we don't waste any type of material. For example, in dye penetration, you have the dye, then you also have the concealer and developer, or all of those things. So we'll be wasting all of those sprays, as well as those sprays are highly toxic.
Yeah.
So why do we still use that on board a ship if I can just use a very simple ultrasonic test?
Yeah, it's a
Well,
good question.
it's dye
Actually,
learn.
yeah, yeah. Actually, penetrant testing is mobile, but ultrasonic testing requires instrument, and we need to carry. And if you see ultrasonic testing, there are numerous other things we need to carry. Like they will say some dead weight. This is for calibration. To be say the exact procedure. This is the reason why ultrasonic testing is not used, and penetrant testing and this magnetic particle testings are mostly used in field. Yeah,
that's why he was saying that it is only can be used near the source, near the source. Like we
yeah,
have some uh, instrument that is really required. It is not mobile like penetration, dye penetration. In dye penetration, we
I
use
think,
dye.
excuse me,
and it
can
can
I
be carried
add a
any
point
place
on
because that is an aerosol spray. It's easy to carry.
it? Can I add one thing on it?
Yes.
Yeah,
That I think that we do not use ultrasonic testing on ships as we already have a lot of mechanical voices of the engine in the engine rooms, right? It is also a sound wave,
Hmm.
so it might interfere with the readings in the test subject, right?
yeah,
It is worth noting because it is like it is not a heavy setup. One can easily carry it on two hands. The ultrasonic testing one. Only a probe and the digital display which is attached to it now in the newer forms generations. I think it's the interference of the already existing sound noises of the ship.
Okay. So, Avito, what was your original question? Let me write it. No, maybe it
Yeah.
if it
My
asks.
original question to all of these explanations. So
Uh,
immediately, as per let's say for example during the interview, the question is explain the different types of non-destructive testings. So then all of these different methods were mentioned. So then the first cross question was in the ships, if suppose ultrasonic testing is so good that we don't have to spend any material and we can just reuse it again and again. And in dye penetration testing, I'm wasting all of my sprays because I have to spend on the dye as well as the developer and all of those things. So I'm wasting some sort of spray. At the same time, this spray is highly toxic. Then why should I, or why do the ships still use dye penetration testing compared to ultrasonic? Is the cross question.
why still use dye if ultrasonic testing is so good?
And let me try another reason is, and I think the dye penetration test is used where we want high accuracy readings. I think there might be some errors in ultrasonic one, but in dye penetration testing, our readings would be perfect, near perfect, due to the capillary action.
But ultrasonic seems to be having using probe using digital uh, that digital thing screen and
Yeah,
all.
you're right. But if we see in detail, right, it is production of one form of energy and conversion of that form of energy to another, which could lead to some kind of losses, right? If the hole is only of deformities of only depth of 1 mm, it there might be a chance that the ultrasonic one might detect it, but will let's say read it to be of 0.5 mm, not accurately 1 mm, because in the conversion of energies by the transducer there might be some energy losses.
Okay.
Yeah, so these are all
I will
some
be
possible
posting the exact reason from after searching this. Don't worry, guys. But uh, for the
because
time
one
being,
thing
uh,
is in terms of dye penetration testing, you're taking into account human error because or the possibility of human error because let's say the dye is being visible. If the human can't see it because as you mentioned, the dye penetration testing is done in these super tight or weird spaces. So what if I don't see the actual dye over there? I might think there's no crack, but there is a crack, and then some damage might take place. But in the ultrasonic, maybe that there might be some losses and it doesn't give us the accurate reading, but as long as it says that there could be something, I can go and further investigate. But with dye penetration testing, even if it shows and if I don't see it, I'll say it is all good, and I might pressurize the thing to full power and it could explode, causing damage to some person or the crew or whatever. Apart from that, you also mentioned about the engine noises. I'm not sure, it could be that that is an interference, but I think Karthik or someone was mentioning that these work at very high frequency. So the lower or like normal frequencies that the engine is producing cannot match or interfere with that because the ultrasonic is not scanning for all sounds. It is only scanning for the high frequency that it created in the first place. So maybe Gyan can do some further research and post the exact question.
that's why I written. Na? If I don't find this, I will my digestion will not take. Okay. So it was good question indeed. I have to prepare. We have to prepare before interview.
Yeah, it
Okay.
was a very nice question to
Okay. Uh, moving with the next question, we have discussed ultrasonic testing, magnetic particle testing, dye penetration testing, radiographic testing. Okay. So what is radiographic testing?
in radiographic testing. We use two types of uh, electromagnetic waves, that is the X-rays and the gamma rays, depending on the thickness of the test subject. If the test subject is thinner, then we use X-rays, and if it is somewhat thicker, then we use gamma rays. And the working principle is just as same as the magnetic particle testing, where the EM waves are used as a signal to detect the cracks or portions.
Okay, so there, whenever there will be some discontinuity in the uh, testing material, there will be the accumulation of the radiation. Okay, so what I
No, no,
got,
I don't
something like
know
this.
the
No,
nitty-gritties about that.
we have also heard,
How
we have also discussed about this concept, like in magnetic particle testing what actually happens now when flux, that magnetic flux is magnetic particle is speckled, then whenever there is some crack or something discontinuous continuity in the material, there their concentration of that flux takes place, accumulation takes place. Yeah, Harshal.
See, the magnetic particle testing is something like if you are passing the waves through it, and if there's a crack, that wave will leak, and then the particles that you have sparkled on the surface, it will accumulate there. So that magnetic field you are passing through the material, that will attract those this metal particles. So you get to know that there's a crack over there.
Okay, okay. So here I can't say that like there will be the accumulation of radiation where the discontinuity, where the defect, where the crack in the testing material. I will, hmm? It is not like correct to say. It is just my speculation.
Well, like there will be a change in intensity. So wherever the crack is there,
Hmm.
maybe the magnetic field will slightly increase. So even some small magnetic particles from the surrounding part will get stronger, attracted to the crack area. So you can imagine, we immediately see that a lot of particles are suddenly, clumping in one area. That means over there is some defect, which is why the intensity has become stronger at that point.
No, no,
Is it something like that?
yeah, I am talking about radiographic testing because he said that the radiographic testing is much similar than the magnetic particle testing. Okay, where
no, 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 no. I'm sorry
principles.
to misguide you. I I did not intend to steer you in that direction. I only know the half mechanism, that is the X-ray and the gamma ray. Other than that, I also need to study
But you
about
are
how the reading takes place or how the measurement is done.
okay.
I only know the mechanism.
I also barely know that the discontinuity which is found now, that is like the discontinuity in the magnetic particle testing. What I am meaning about discontinuity in material in specimen material is that crack. What I am meaning. So in crack in magnetic particle testing, there will be the accumulation. There will be because of electromagnetic flux leakage, and so in case of ultrasonic testing, what happens, we use two rays as you told, X-rays and gamma rays. Gamma rays is for denser material, X-rays for thinner material. So the radiation intensity may change. Okay, but yeah, Harshal.
Yeah, seeing the X-ray, in the radiographic test, what happens is you have, so let's say you have a metal tube, and beside, below that, you have a film which is recording the X-rays till it is passing. Right, so you have the X-ray tube which is emitting the radiation of wavelength similar to the X-rays. So when you're passing the X-rays, this that film below the metallic plate which you are detecting, it is recording the X-rays that are falling. So if there's a crack, so what will happen that X-rays will come with more intensity, and you'll get a spot where the crack is exactly. Like it's like the X-ray you are taking. Say you have a crack in your hand, and you are doing X-ray. So it is similar to that.
Yeah. Okay. Here I have find something that the in a radiographic testing, the radiation will shows discontinuities in the material due to the strength of radiation. Okay. So anyhow, we got the basic idea what is actually it is. Okay, that will more than enough for the time being. Okay, we can further move on to the next question. Next question is okay. What is oil mist detector and where it is used? Anyone, guys?
Oil mist detector, did you say?
Yes.
Uh, I'm taking a guess. I have not read about it, but I think oil mist detector is used in the on the ships as to detect if there is an uh, if there is an concentration of an inflammable oil or uh, corrosive oils in the air, because we use a lot of lubrication oils and the coolant oils in different parts of the ships in machinery. Right? So it might be that during cleaning or due to some physical factors like wind, the small particles of oil might be carried away in the air, and we do not want that,
No,
because it will in the end stick to machines, might do corrosion, or might create slippery surfaces.
okay.
It's
So
just a guess.
it
I do
was
not know
guessed.
about it.
Let me tell you, your guess was very much closer. Like you said, it is related with some mist formation. Yes. You said we use lubrication oil on the ship. Yes, and it can cause not corrosion. It can cause explosion. Okay. Anyone else? Because it has been asked to the by the Brajanga sir to Jay, one of our group member. Okay. Anyone else having idea or can any guesses? Because we can't leave the question which has been already asked in interview. What if we are going to face? And since Gyan takes some speculation, it is much better than speaking nothing. Anyone like to try? What is oil mass detector? Avito we have heard now in case of while the in the last lecture by Arvind sir, oil mass detector.
Yeah, he was talking something about oil mist detector,
Mm,
and maybe he was talking about how the oil mist takes place. So he was talking about that oil mist is going to take place when you have bearings that get spoiled. They might create some hot spots,
um,
and that is when the oil will turn into a slightly small bubble form or mist, as he says,
mm,
and then that can be a fire hazard. But
mm,
I'm not sure exactly on how the oil mist detector is going to detect these small mist of oil, or even where it is exactly located. So
okay.
something he was mentioning that it might be placed in multiple locations,
Mm,
but we need a proper concrete answer. So we'll
okay.
have to definitely look up into that.
Okay. So
We
the
should look up into that, but we might remember in 12th NCRT in the electrostatics, there was an oil detecting oil mist oil drop test, right? If you remember that if one drop of oil is remains static between the charged plates of the cylinder, if you recall,
that oil
it
Mulliken
might work
test
in
to
that way.
find the number of electrons, something like this. No idea, bro. Let me explain. Okay, what actually it is, what I know, and also let me tell you. This was not the question that has been directly asked to the GME aspirant. Actually, what was the question is that tell me about the safeties of auxiliary engine. Okay, so what he said, he by mistake he take the name of this safety also, oil mist detector. Okay, what he said, the safety of auxiliary engine is like low loop oil pressure tip, high jacket water alarm, that will be discussed later. Okay, he said oil mist detector also, but the problem is oil mist detector is a type of safety for two stroke main engine, not for auxiliary engine. One thing is that. Okay, now coming to the oil mesh detector, how it works as a safety. So the oil mesh detector, as we know, in a case of two stroke main engine, there is a splash lubrication in a crankcase, isn't guys? Okay, so
Yeah,
in a case of splash lubrication, if there is some hot spot in the bearings, if by mistake if there is some hot spot has been formed in the bearings, hot spot is the region, is the cold region that has been, is the cold region, Avito, it was the cold region na, that has been formed.
Hot region.
Hot region, no, let me check it, let me check it. Hot spot is the region, okay, it has gone. Guys, I am not finding it, but for the time being, as far as I know, that hot spot is the cold region that has been formed at the bear. No, it's a hot region. It's hot region, okay, because it has been formed by the rubbing of bearings in the cylinder, in the crankcase, okay. So what happens now, when splash lubrication takes place, the splash lubrication, the lubrication oil gets converted into vapor, and when that vapor converted again into the oil form, like in condense, they make the region of cold region, okay. There is some temperature difference created inside the cylinder, and that can cause fire like explosion. In a case earlier, when it was lubrication, in the form of lubrication, the particle size was slightly bigger, and when it becomes vapor and then it condenses, the particles become very fine, and so it is very much vulnerable to catch fire. So there is a chances of catching fire in the crankcase, that is known as explosion. So for that, we have there is an installment of oil mist detector that signals that how much amount of that mist is created, and what is the what is the standard level that can be created in that. Ovito, am I making sense?
Yeah, something along those lines.
Hmm.
But we'll just now check out the exact working principle on how the mist, I mean, the how the oil mist detector is going to detect these particles, and then how it basically sends the signal, or the inner workings of it is what we need to work upon now.
Hmm.
So we
Hmm.
understand how the hotspot is created,
Hmm.
and then what happens when the hotspot is created. So now we need to mainly focus on uh, how does the oil mist detector do its job, or what is the inner workings of it.
Other guys, you people got me, got my explanation, got some idea what actually it is.
Yeah.
Yeah, I have asked also Sandy this question, and he explained something like that only, how Arvind sir has explained it. God's sake, why am, yeah, oil mist detector. Because of the defects in machinery, okay, there will be some hot spot in the crankcase. Because of this oil mist created, because of high temperature, lubricating oil will form vapor and then condense, then oil mist will be created, and oil mist detector will detect the formation of oil mist. If there will be the more oil mist detector, there will be a chance of crankcase explosion, there will be chance of lube oil can catch fire. Yeah, I was right, guys.
Yeah, so this is basically the same thing of what Arvind also mentioned of
Hmm.
where it is used and all that. But
Hmm.
maybe we with a cross question to Arvind sir to go a little bit deeper on the inner workings of it. So, like, what exactly is happening inside the oil mist detector? Because if this is coming as a cross question in the interview, then we might have to go a little bit deeper.
This much will be not be that much okay to speak in interview. If, uh, because to
No, no,
knowing this as a GME aspirant is also a big deal. Anyway, so why it is used in two-stroke engine? Because two-stroke engine, we have splash lubrication, we have uh, so much lubrication, okay. So that's why, that is the reason. Now coming to the next questions, guys, we should, yes, Avito.
You mentioned in two-stroke engine, but you said that this came as part of the auxiliary engine, right?
Yeah, by mistake,
Safety.
by
Yeah.
mistake, Jay said that oil mist director is also part of a safety in auxiliary engine.
Okay.
Then he cross questioned what oil mist detector, and he was not able to explain it. I think he
Okay.
had heard about this oil mist detector, and he just spoke in a case of. So I asked to one of my mariner friend that where actually it is, and for which engine safety. If he is asking about auxiliary engine safety, not two-stroke in main engine, so I will be not answering that oil mist detector. I will be answering only low lube oil pressure trip, engine overspeed trip, jacket high temperature alarm and trip, okay, relief valve and other things, fuel oil. There are so many safeties in the auxiliary engine, like fuel oil leak of alarm, lube oil low pressure alarm, and all.
Shared 10 to 12 of them in the group, right? So
Yeah.
we can just once.
Hmm. That video is also coming now, in which Arvind sir told about that. Okay, but 4 to 5 trips we are mentioning, that is more than enough. Huh?
Yeah, yeah. So maybe
Hmm.
we can just stick to the major ones so that
Hmm.
they are enough.
Okay, so major ones are just like this only. Okay, moving to the next question. What is bursting disk and temperature at which it will burst? Guys, it's passes on you. Rakesh, Ajaz bro, what is the answer? What is bursting disk? How will you explain?
Basically, it is a copper disk which bursts when the pressure limit exceeds over a set of predetermined value. Okay,
Okay, and
like we
temperature.
have
Hmm.
it is 1.5 times of working pressure.
I asked temperature. Any idea about that?
Temperature
Temperature
can vary,
for
right,
Celsius
according to the
or something.
applications, right?
Yeah, you
I
don't know
don't know
about. Yeah,
exactly.
I also don't know. Uh, Harvinder, are you having also your interview? Why you are not trying to speak up? What is busting disk? How will you explain it if you have been asked in interview?
I think bursting disk is a copper disk, which act as a safety disk which bursts when the temperature rises above the predetermined temperature. So it is fitted at the intercooler or aftercooler. So it bursts due to the leakage of the gases.
Okay, and what is the temperature at which it burst?
That was I was searching for the temperature.
Okay, if you search it now, also post it in group. Okay, that is your liability.
Okay, okay, definitely.
Okay, make sure. We know about that pressure. That is pressure at 1.5 times of working pressure it bursts. Actually, what bursting this? If I have to explain it, I will to just give me feedback. It is the correct way to explain it. Not if the question come to you. Okay, bursting this is a safety device that is mostly in compressors. Okay, in intercooler and in aftercooler, it is usually made up of copper or aluminum disc that burst whenever the presses crosses the limits. Okay, and it bursts and it excess the it releases the excess pressure by draining of water of intercooler and aftercooler. That will be okay, or
Yeah, we can
I missed
also
the main
like say
part.
that.
How let's talk about the breaking of the tube and all of the high pressure air meeting the water and all of that part was skipped.
Yeah, yeah, we have to say about all that. Like there is a pipes in that, so that if there is any leakage, it will release, it will have the high pressure and it exerted on the water,
Okay,
then it
so
will burst, like you said on that day.
I have to be more detailed. Okay, okay, all
So
right.
we have mentioned how bursting this is working and under what circumstances it will burst. But what you have not mentioned is in what cases will this high pressure form in the intercooler in the first place, which is where we talk about the bursting of the tubes and all of that.
Abito, your voice is not like not audible that much.
No, it's not audible now. So that
All of a sudden, you got on low pitch.
my check, my check.
Yes, mic check. It's right now.
Okay, so what I'm saying is,
Hmm.
in your answer, you've spoken about how the bursting disk works and at what stage it will activate.
Hmm.
But what you have not covered is how, in the first place, does the pressure inside the intercooler increase to such a dangerous level? So that
Hmm.
is what you need to focus on in your
Wow.
answer.
Okay. So how pressure gets increased? That is the because of the pipe in which the gases high pressure and high temperature gases, that there is a there will be the leakage. If there will leakage, then only the pressure of that intercooler will increase, na system of increase.
I think due to certain blockage in the pipe, the pressure will increase.
Yeah, so this is going slightly deeper where we say that how did that pipe break? Was the pipe, just getting rusty, or did it have some kind of weak spot, or just over time, or whether there was some blockage? So once your pipes which are carrying the high pressure air, once those break, it will send this high pressure air of let's say 30 bars into the water which is just flowing at 1 or 2 bars. So your compressor casing of the intercooler is not meant to sustain the 30 bar pressure, so it could explode the entire thing. So to avoid this large explosion, we just have the bursting disc so that in case this 30 bar air, if you're talking about the higher a second stage of compression with that side, if this 30 bar of air goes into the water, we know water is incompressible. So it will pressurize the whole water also to 30 bars because it is going to keep on trying for the pressurized air to come out. So the 30 bars of water now could damage the entire walls of the intercooler or aftercooler. So that is why in this case the bursting disk will activate and save the rest of the enclosure by just allowing the water to drain out.
Explosion or implosion?
Explosion.
Okay, all right. Let me try again. Okay. So I will be saying that the busting disc is a safety device that is mostly used in compressor, compressor intercooler bodies and aftercooler bodies, in which the heat pipe, the pipe is there, in which the high temperature gas and high pressure gas is passed through, and in intercooler bodies that consist of water. So in a case of any leakage, any blockage or any weak spot, the high pressure gets in touch with the water that is at low pressure, that will exert that much. Suppose the pressure of that gas is at 30 bar and the water pressure is normally lesser than that, so it will exert that much pressure, and so at that time busting disk will bust and will save the system from getting exploded by just draining off water and releasing the extra pressure. Much better before that.
Yeah, so this attempt is much more clear and covers all of the topics.
Hmm. I lack so many details while explaining. I thought that in a case, I thought I have to be concise at the same time, but detailed one also.
Yeah, so you can be concise in cases of saying that you if you skip on saying like how the pipe busted, so you don't have to say the weak spot or blockage, but the main thing you have to say is there was a leak. So
Hmm.
that is the key point that you should not miss, that the leak is there. That is why the air is mixing with the water. So by default, it does not mix on a normal day.
Hmm.
If
Got
you're
it.
planning on making it
I
concise,
think you should be concise or speak in detail on the basis of who is your interviewer. If Rishi is your interviewer, speak concisely.
Hmm.
If Braganza or the other guys of the interviewer, speak in detail.
Hmm. Very much agree. Very much agree. Okay. Now moving with the next question, the one question that is pending, guys. What is the temperature at which bursting disk burst? Okay, that has to be like please search on that and also post on group that what is actually the answer is. Okay, now coming to the next question, what is Pascal's law? I will be asking to this question everyone, starting with Harvinder. Say it, whatever you know. Harvinder, are you there? 1, 2, 3. Okay, Abhijit, go ahead.
There in conical there is incompressible fluid like water, and when we applied a pressure on that, then it equally the force is applied on that, and it is incompressible, so it can moves in all directions like a force is applied on that. Its example is a press machine.
Okay. Harshal? Yes. Yes, go ahead.
Yes, so the Pascal's law says whenever the pressure is applied at a point in the fluid, it is equally transmitted in all directions. That means if you apply the pressure anywhere in the fluid, as we know the fluid is incompressible, that force will be transmitted equally in all directions. And if I give the example, then I can give the hydraulic press, hydraulic the jack, then we have the hydraulic braking system.
In hydraulic jack, what we do?
Like we are applying the force by our hand and we can lift the car. Like the Pranit sir has given example in the litmus packet.
By hand?
Yeah, if you can say that, it is used in the mechanic place
Actually,
where
what
you
we
apply the
do
little force.
now, since for pressure is force per unit area, so at one side we minimize area and maximize the force. Okay, maximize the pressure. At one side we maximize area and minimizes force. Like that, we by manipulating the
By
force.
increasing the area, you can increase the pressure. That's what you're saying, right? On the one side the area is less, on the another side the area is more. So if you are applying 10 newton force, it will the area is 10 times bigger than the area at the start, the pressure will be more, right?
Pressure
That's
will
what
be
you're saying.
pressure will be same at
Same,
both.
but it will be applied on the larger area, right?
Pressure will be same on both sides, the force applied will be different. So what we do,
Yeah,
by manipulating area we take the more application of force, like we increases the applied force. If we are here applying 10 newton, then by manipulating area we will be getting here the applied force will be 100 newton, isn't in the case of hydraulic jack?
yeah, correct. By increasing the area, we
Hmm,
get the more force.
correct. Anyone, guys? Anyone else? Gulshan has been joined. Gulshan, are you also having your Anglo interview?
No, sir.
Okay. So what are you up to? What are you doing? Like what are you pursuing? You have passed your mechanical? Hello?
Yes, yes, yes. I am passing out.
Have you applied for Anglo?
Hello?
Have you applied for Anglo?
No, no, I am applied for Sims.
Okay, all right. Okay, guys. Ajaz brother, you are not speaking at all. Okay, all right. Moving with the next question. Okay. let me explain. If I had to explain this question, what is Pascal law, I will be explaining like this. uh, the pressure applied in an enclosed region will be transmitted equal at in all direction. Okay, and the application of Pascal's law we see in the lifting of big materials, like in a case of hydraulic press, hydraulic jack. Okay, there we change area and we get higher force, higher applied force. It is making sense, Evito? Yeah, I'm lacking.
So, Gyan, if you watch
Hello.
on YouTube on the Merchant Navy Decoder channel,
Mm,
in one of the interviews given by Praveen sir, uh, the one who had broken his finger, he asked the exact same question,
mm.
and student has missed out on the keyword incompressible fluid. So
Yeah,
if
that's what I said, Gyan, in the start,
you
as
will
the
have to
fluid
click
is
back.
incompressible. You missed out on that.
These are the things, minute details can be the failing point. Okay, the, okay. So pressure applied to incompressible fluid will be transmitted equally in all direction. Okay, in an enclosed region. So it is a law of transmissibility. This Pascal law is nothing but law of transmissibility. I have read this line somewhere. Okay, got it. Yeah, I will be putting this mind, nothing to forget the keywords. Like now, the next question is, what is Archimedes principle? Yes, Harshal, go ahead.
When a body is wholly or partially submerged in a liquid and a upthrust force acts on it, which is equal to the weight of the liquid displaced by the body. And that upthrust force is nothing but a buoyant force,
What is the
which
formula
is
for
equal to
Bayern
the weight
force?
of m into g. So m we can write it as this velocity into density into g. So it depends
Velocity
upon
into
the
density,
density.
volume into
It's
density.
rho
Sorry,
Vg.
volume into density.
Density,
My bad.
volume, and
Volume
weight.
into density, g. So volume is the volume of the body that is submerged in the liquid. G is the gravity, as we know, and density is the we know the density of the water.
Rho Vg. Okay,
Yeah, rho Vg.
density of the fluid, and volume of the fluid displaced hoga, that will be the volume of not body.
Because volume, the volume your body has, that much amount of water you are displacing, right?
Okay,
Not
so
more or less than that.
suppose if whole body is not displacing the whole liquid, like there is half body upside the liquid surface and half body in the uh, water. So if you are telling that volume of the
So,
body at that
so
time,
if that's the case, the part of the body that is submerged inside, so that much volume we are considering there. Like
see,
if they ask me,
uh, I have just memorized the thing that the fluid displays, volume of fluid displays every time, because there was a lots of question on exam with the India bigs, that what is that actually volume is. You must have solved, you people, resonating me.
that volume is exactly the volume of your body that is submerged. That's why in the statement you see when the
Yeah,
body is
yeah,
wholly or
yes,
partially submerged in the liquid.
you are right, you are right. But you know what I am saying, that you haven't seen the questions like that. Which volume we are talking about? In option there are four options, and the one option with the volume of the fluid that is displaced. Gulshan, anyway, moving next. Anyone else try to explain? We are just practicing how we will be explaining. These are the common question.
No,
Okay,
my
sorry.
explanation will be the upward force exerted on a body immersed in a liquid partially or fully will be equal to the weight of the fluid displaced by the body. And the direction and the point at which the upward force act is the center of the mass of fluid displaced.
Making sense. Anyone else try to explain? Yeah, Abhijit, go ahead.
Guys, I have one question about that.
Uh,
Is that the displacement of water is depending upon the density of liquid and mass of the body?
what? Again?
If suppose we can take we can take an example, every time we can take an example with water,
Uh,
but sometime some liquid have a different densities.
hmm.
So if it so there can be a difference between the water is displaced when we use water, and when we use other liquid, then how much displace. There is a weight difference between that.
See, go with the formula. What is buoyant force? That is upward force that acts, that having formula rho Vg. Rho is the density of the fluid. If the density of the fluid, the upward force acting will be the more. So if we are drowning somebody in fluid, in water and in oil having high density, in that oil the body will be drowned less because upward force will be acting more. Getting, Abhijit?
Density of oil is
Yes,
less,
yes,
bro.
I get it. Got it.
I just supposed mustard oil, not that kerosene
Yeah, yeah,
oil.
okay, okay.
Okay, mustard oil will have na density more.
Yeah, yeah.
Yeah. Every time I got confused because the moment I hear oil, I always remember mustard oil that is having more density. Then after I got to know the oil we commonly called in this engineering field is the oil, crude oil, the petrol, gasoline, or that diesel oil that is having density 991 something. Isn't Harshal 911 kg
Yeah,
per
yeah,
meter?
991 kg per meter.
Okay, less than 1000. I got you. Okay, so I will be explaining, like, let me also explain. I will be the explaining lines. I will be explaining same like this. When a body fully when a body is wholly submerged, अरे यार why am when a body wholly or partially submerged in a liquid, in a fluid, an upward force acts on the body, and that upward force is known as buoyant force, is known as Archimedes principle. And buoyant force is rho Vg. Rho is the density of the fluid, V is the volume of the fluid displaced, and G is the gravitational acceleration. चलेगा चलेगा guys, this explanation?
Yes, yes.
Okay, moving with the next question. Yeah, along with you guys, I am also learning. Thank you for being here. Okay. Now we will be moving with the Bernoulli principle. Most common question. Okay. Anyone? Ajaz bro, you have turned off your mic. You want to explain something?
Nothing here.
Okay, all right. Rakesh,
Yeah,
Bernoulli
let me
principle, try
explain.
na.
Okay, Bernoulli's theorem states that for a fluid flowing, an increase in the speed of a fluid occurs with a decrease in the pressure energy. Okay, and the sum of the energy will remain constant in a pipe, like total energy will be the same. Is it okay? Or we have to tell him the assumptions also.
What are the assumptions?
Yeah, it should be a what you said me on that day. It should be a flow should be idle and streamlined. It is a rotational flow. Uh, like only this I know. This much I know.
Flow should be ideal.
Yeah, flow should
Flow
be
should
idle
be
and stream.
I
flow.
It
think
should be or it should not be. I'm
Should be
not
ideal.
very much. Should be ideal, na?
Fluid should be
Yeah,
ideal.
it should be ideal. Yeah.
flow should be steady.
Steady flow, steady flow. So Bernoulli theorem is based on the principle of conservation of energy, that states the if fluid flow along a streamline, the pressure energy, the summation of pressure energy, kinetic energy and potential energy will be constant along that streamline. And the assumption of Bernoulli theorem is the fluid should be incompressible, non-viscous, ideal and irrotational, and the flow should be steady and streamlined. Making sense?
Uniform as well.
Friction losses are negligible.
Non-viscous, that's why I am saying na viscosity is the reason for friction na.
Okay,
Okay,
right.
making sense? Okay.
Is it necessary to tell him the assumptions?
The more detail you will go, the more
The more cost questions will be there.
what is steady flow, what is uniform flow. Steady flow is the flow which is constant with the time, like a d by the properties of fluid do not changes with the time, and property
dV by
and
dt.
dB by dt is constant. In a case of uniform flow, the direction of fluid remains constant, and direction in the particular direction the speed of fluid remain constant, something like this. Yeah, always we got confused between uniform flow and steady flow. Always, yes, Harshal, I think Harshal have some differences.
Yeah, so in steady flow, if you guys want to remember, in steady flow, it's like it does not change with time, but it changes with space. And in the uniform flow, you see it will change with time, but not space.
Very correct. Are you have you heard have you also learned from Venugopal sir?
No, I have read it in my engineering book. Like
I
I have made the differences
okay, yeah,
to remember it.
steady flow will not be changed with respect to time, and uniform flow will not change with respect to space. Okay.
Is it right to say that
properties of the fluid.
Okay.
Can you
Now,
mention the properties of the fluid?
okay. Now getting. Suppose it's a streamline flow. Okay. Suppose it's a flow. Okay. And it's a point A. My fingertip is showing. My fingertip is showing. Arey yaar. This. Okay. Let me put. No. I have given so much time to understand it, the difference. Okay. Okay. Okay, guys. Come on, see it. Suppose there is a flow and there is a point A and point B. Okay. So if on at point A the velocity is 5 meter per second, and at point B the velocity of a fluid is 10 meter per second, the fluid will be passing here. The next fluid, if the successor fluid goes on, the next fluid which comes and occupies this place, at this place, if this velocity of the fluid will be 5 meter per second, that will be the steady flow. Okay, that with constant space it will be not changing. What was the reason? Yeah, Harshal say it now, I will be relating. In a case of steady flow,
Yeah, it doesn't changes with time, but it changes with space.
yeah, it
At a
changes.
particular point,
Yeah. It doesn't change with time, but it changes with space. Now there are two space, that is suppose a flow, there is a two space, space A, space B. At space B the velocity of fluid is 5 meter per second. At space A velocity of fluid is 5 meter per second, and at space B velocity of fluid is 10 meter per second. So it will not change with time. On increasing time, here the velocity of other fluid that is passing this point will be 5 meter per second, but it will change with speed, with space, like on space B the velocity will be 10 meter per second. Okay. In a case of uniform flow, this point, the velocity will be same. If here is 5 meter per second, here will be also 5 meter per second. Harshal, am I making sense?
yeah.
Okay. So in a case of uniform flow, the velocity of fluid, the property of fluid do not change with the spaces. Spaces mean the points in a flow. Okay. So here, if it is here 5 meter per second, it will be also here 5 meter per second. In a case of steady flow, if it is here at constant speed, if it is here 5 meter per second, and if it is here 10 meter per second, then the fluid that is flowing and the next section of fluid, when it comes here, it will have same velocity 5 meter per second. So at constant space the velocity will be same in a case of uniform flow. Okay guys, until unless you are not going to read by yourself, learn by yourself.
Yes, in uniform flow, velocity is constant,
uh,
and right. If we
uh,
talk about the steady, the amount of fluid flowing per second is constant.
velocity of fluid is constant in a direction, in a space.
Yeah. Yes.
Okay, not with time, you are getting me? Like at 5 minute, okay, if 5 minute, if in a uniform flow it is having 5 meter per second at every point, in a case of 7 minute, the two after 2 minute, it will, you will be seeing the 10 meter per second velocity, and that will be equal like in every point of space.
Yes,
So
right,
so
right.
with time it will not, it will be changing, but if here it is changing, it will be changing at every space, like uniform flow. Okay.
क्या समझा रहा है?
Anyway.
कंफ्यूज कर दे रहा है और
Anyway, मैं तो समझ गया.
यार सिंपल है यार, उसमें स्टेडी फ्लो में टाइम के साथ में नहीं होगा, जो क्रॉस सेक्शन होगा, क्रॉस सेक्शन एरिया होगा,
अब क्रॉस
उस
सेक्शन
सब
कहाँ
जगह
से
पे फ्लो
आया?
डिफरेंट होगा.
अब क्रॉस सेक्शन कहाँ से आ
ठीक है.
रहा? अच्छा, क्रॉस सेक्शन.
और यूनिफॉर्म में क्या होगा, टाइम के साथ में वेरी करेगा नहीं, जो भी रहेगा क्रॉस सेक्शन जो बता रहे हो एरिया.
नहीं, यूनिफॉर्म में टाइम के साथ वेरी कर सकता है, बट स्पेस में नहीं वेरी करेगा.
यार उसकी उसकी जो वेलोसिटी होती है ना, वो टाइम के साथ में नहीं करेगा क्रॉस.
अरे
यार छोड़ना, इससे छोड़ बाद में.
let's leave it. Okay, moving on the next question, guys.
यार ज्ञान,
हाँ.
यार you are talking about Bernoulli principle. You didn't mention the key point. Actually, Bernoulli principle is applicable for the dynamic fluid, and Pascal law is applicable for the static fluid.
Yeah, thank you for remembering me. I was about to mention. Okay, now I will be further adding the concept why he said dynamic. Bernoulli principle is for dynamic fluid with having velocity. Since you have seen the example of flying airplane, there also Bernoulli
Yeah.
principle applied. But the cross question is, if air is compressible, if air is not ideal, how it is you are applying Bernoulli principle? So there is also one assumption, fluid with high velocity. Fluid with high velocity can be applicable for Bernoulli principle. Okay. So and this much will work, or I should explain something more about how aeroplane fly and how Bernoulli principle work in aeroplane?
Yeah, please just go on the detail. Yeah.
Yeah, okay. So actually what happens now, guys, moving a have you heard some output of a line from Bernoulli principle that the moving air creates a low velocity, a low pressure region? If air is moving high with high velocity, it will
Speed.
create a low pressure region. Okay, so now,
Yes, yes.
okay, so if air is what happens, the wing of aeroplane is made like this. Okay, wing of aeroplane is made like this only. Let me explain. Okay,
Aerofoil size.
aerofoil, like aerofoil structure.
Aerofoil.
In aerofoil structure, they made like this, that the below portion and upper portion, below portion moves with high velocity. Sorry, moves with low velocity.
No. Upper portion is
Sorry.
moving high velocity,
Ah.
so create the low pressure side below the wings.
And lower portion creates a high velocity, and you know, high pressure to low pressure, fluid flow from high pressure to low pressure. So here we have low pressure region, here we have high pressure region that lift up aeroplane. Okay, so wings of the aeroplane is made such like that, that the distance is upper side of distance is more. Okay, so it will have to it will have high velocity to cover that distance. So high velocity will create low pressure at that region. If you will go in much detail, then you will have this formula na, distance upon time is speed. Okay, if distance is more, then the speed should be also more, because at the same times you have to, the air has to cover the upper side and lower side of the wing. Anyway, Azaz bro, is it enough?
Yes, yes.
Okay, moving with the
Yeah, yeah. No.
next question. Working of fusible plug. Now starting with the what is fusible plug. Before starting this fusible plug, Avito, had you this idea, because you are good at explaining and I am worst at explaining the thing. And after only after people believe me when I get selected in Anglo. Okay. Avito, are you there?
नहीं भाई बहुत सुधार हुआ है पहले
Yeah.
से तो बहुत ज्यादा सुधार हो
अरे
गया
thank you भैया, thank you, because of you people only in starting from the like I think 1.5
क्योंकि मुझे पता है ना एकदम एकदम स्टार्टिंग में से मैं सुनते आ रहा हूँ
हाँ हाँ,
तब से अब मैं बहुत ही ज्यादा
बस सिलेक्शन हो जाए आप लोगों के साथ. ओके ओके, आई विटो, आई थिंक सो गया विटो. मूविंग विद द नेक्स्ट क्वेश्चन. व्हाट इज वर्किंग ऑफ फ्यूजिबल प्लग? हरविंदर, वुड यू लाइक टू एक्सप्लेन?
Yes, I what I remember is fusible plug is used to cut off the supply of fuel for to protect it from damage in case the water indicator indicates the low water level. So it protect the boiler from getting damaged due to lower temperature.
Due to higher
So it is
temperature.
yes, due to higher temperature. Sorry.
हाँ यार. So they
Yeah,
don't make this mistake in interview time. That's why we are here. जितने भी गलती
right,
करना है
right,
प्रैक्टिस पे कर लो भैया. ठीक है.
right.
हाँ
यार ज्ञान
हाँ.
एक्चुअली फ्यूजिबल प्लग इज प्रोटेक्ट अगेंस्ट ओवर हीटिंग हाँ
ओवर हीटिंग से प्रोटेक्ट करता है, लेकिन जब लो वाटर लेवल शट डाउन होता है और स्टीम
नो
जब
नो नो
बनता है तो लो वाटर लेवल होता है तो बहुत ज्यादा टेम्परेचर बढ़ जाता है, तो फ्यूजिबल प्लग मेल्ट हो
नो नो
जाता है.
actually what is a fusible plug it is a protect against overheating the फिर उसके बाद बात ये आती है कि कहाँ हम यूज कर रहे हैं बॉयलर में यूज
हाँ
कर रहे हैं या कंप्रेसर पे
हाँ.
यूज कर रहे हैं वो डिपेंड करता है ना अगर
कंप्रेसर
बॉयलर पे यूज कर रहे हैं तब देन फिर वाटर फिनोमेना
ना
वगैरह
ओवर हीटिंग
सब आता है
लाइक हाई टेम्परेचर पे ही
हम्म,
तो ओवर हीटिंग होगा. ओके, सही है.
हम्म।
योर हाई टेम्परेचर इन
एजाज
हाँ,
कंप्रेसर पे कैसे रहेगा यार उसको?
वो वाटर बॉटल के ऊपर रहता है. वी हैव आल्सो हर्ड लाइक एविटो वाज एक्सप्लेनिंग द होल
Air bottle,
डायग्राम. एयर
not
बॉटल.
water bottle.
हाँ एयर बॉटल, सॉरी सॉरी हर्षल, सॉरी.
Yes, yes. After the after cooler, I think.
अब सबसे लास्ट में एट द लास्ट वेयर वी कलेक्ट द एयर बॉटल, देयर ऑन द अपसाइड वी गॉट fusible plug to maybe for the protection of that, if there is so much temperature of that air bottle that can cause explosion, so that's why fusible plug is fitted there to cut off the
Yes, there is
uh,
lube oil carry over with
yeah.
the air, so that the lube oil do not catch fire due to overheating. So I think that's why
No, no, no,
fusible
no.
plug is.
Now I am getting. Actually, what happens now? Fusible plug, when fusible plug cut off or melt na, it supplies, in a case of boiler, it supplies water inside the boiler to make it cool down. Whenever low level water shut down, low level water condition is there.
Yeah,
Any
but
agent,
there is no
I think
water
it cut
at
off
that
the
time.
fuel supply.
hmm?
Case of boiler, it cut off the fuel supply.
Cut off the full supply.
Yeah,
I was knowing that it will like when
Yeah, steam will go there in the downside and it will just.
it will not allow water coming inside in the low water level region.
ठीक है, हाँ, उसमें जो स्टीम ड्रम है उसमें पहले से ही वो नहीं रहेगा पानी, वाटर का लो तो तभी होगा ना,
लो
फिर
होगा।
फ्यूजिबल प्लग मेल्ट
लो
होगा।
लो होने के बाद क्या होगा, व्हाट हैपेंस के फ्यूजिबल प्लग जो है वो मेल्ट होगा। मेल्ट होगा और
हाँ,
फ्यूजिबल प्लग जो है किसी वाटर कनेक्शन से जुड़ा होगा। मेल्ट होने के बाद जो है वो रास्ता खोलेगा ताकि पानी जाए उसमें। लो लेवल जो वाटर था उसको जो है हाई वाटर कुछ मेंटेन करे। ऐसा कुछ मुझे जहाँ तक मैंने किसी के साथ ये डिस्कस किया ऐसा कुछ होता है। मैं एविटो सुन नहीं रहा है, मुझे नहीं समझ में आ रहा है क्यों। क्लियर करना चाहिए ना किसी को। प्रज्ञान।
आई थिंक उसमें देख, मेरे पास क्या था कि उसमें जो स्टीम जो रहती है ना,
हम्म
वो चली जाती थी सब।
हम्म
उसमें क्या था कि जो प्लग होता है उसमें,
हम्म
वो नीचे गिरता है और कॉलोगन मेटल जो बॉडी है उसकी ओपन हो जाती है, तो
हम्म।
स्टीम रशेस होते जाती है फर्नेस में, इसकी वजह से वो बॉयलर को बंद कर देती है। इट विल
अच्छा,
एक्सटिंग्विश द
मतलब
फायर।
जो बहुत ज्यादा गर्म स्टीम है, ठीक है, उसको वो बाहर निकाल देता है, ऐसा कुछ।
तो या हाँ, मे
यस
बी
इट्स
कुछ ऐसा,
राइट।
आई डोंट नो एग्जैक्टली।
ओके ओके, ठीक है, इसको मैं टिक लगा लेता हूँ। पूरा फंक्शन मुझे फिर से पढ़ना है। दैट्स व्हाई वी
वो
पीपल कॉल।
बॉयलर के बाहर नहीं निकलता, बट वो कंबशन चेम्बर के अंदर लेता है उसको।
या
जो
स्टीम
फ्यूजिबल,
रशेस इनटू द कंबशन चैम्बर ना,
हाँ, तो वो
इज
जो
इट दैट
फ्यूजिबल
ऑल्सो?
जो मेटल है,
हम्म
बीच में जो फ्यूजिबल प्लग है वो जब मेल्ट हो जाता है, तो फ्यूजिबल मेटल जो बीच में होलो बॉडी रहता है वो अंदर चले जाता है, जिसकी वजह से स्टीम अंदर जाता है। वो
यार,
जो कंबशन हो रहा होता है वो रुक जाता है, और फिर फ्यूल सप्लाई भी बंद हो जाता है। दे हैव
ऐसे
सम
ऐसे
सिस्टम।
ऐसे देखते हैं। ये पहले पहली बात तो, स्टीम ड्रम में फ्यूजिबल प्लग रहेगा या वाटर ड्रम में रहेगा? स्टीम ड्रम में रहेगा, फर्नेस के पास।
ये सही है। हाँ
अब
हाँ।
अब स्टीम ड्रम में आधा पानी होता है आधा स्टीम होता है। ओके, अब स्टीम ड्रम में पूरा पानी कम होता जा रहा है, लो लेवल वाटर हो रहा है। इस केस में टेम्परेचर बहुत ज़्यादा हो जा रहा है, तो यहाँ फ्यूजिबल प्लग लगा है जो कि गल जाएगा। तो मेरा ये क्वेश्चन है, यहाँ से गला है तो यहाँ से कुछ पानी आके उस स्टीम ड्रम में जाएगा या स्टीम यहाँ से बाहर निकल के चला जाएगा?
स्टीम बाहर जाएगा।
स्टीम बाहर
स्टीम
निकल
बाहर
के,
जाएगी।
और स्टीम बाहर जाके करेगा क्या?
कि वो जो
वो
फ्यूजिबल प्लग का जो
टेम्परेचर,
लोकेशन है ना,
हाई टेम्परेचर
या
से
देख
प्रोटेक्ट
देख देख
करेगा।
ये
डन
इतना यू इको कैसे हो रहा है? ओके ओके, वन बाय वन।
डन। वो
या
जो स्टीम है ना,
हाँ हाँ।
यहाँ से तो बोल रहे हैं ना कि पानी नीचे जाएगा,
हम्म
बॉयलर के बॉयलर के नीचे वो रहेगा ना, अपना अपना क्या बोलते हैं उसको, फर्नेस।
हम्म।
तो वो स्टीम नीचे चला जाएगा,
हम्म
बाहर निकलने के बजाय वो नीचे चला जाएगा, और फर्नेस बाहर निकाल रहा है ना, उसको बाहर
हम्म
नहीं निकालना, वो नीचे चला जाएगा उसको, बॉयलर को, हाँ, और बॉयलर को वो जो अपना फायर होगी फर्नेस उसको बंद कर देना,
हम्म।
तब स्टीम उसमें जाएगा।
ओके।
ऐसा कुछ मैंने पढ़ा हुआ, मेरे को एग्जैक्टली याद नहीं
मुझे
है।
जो है, आई लेट मी राइट यार, फिर से देखना है मुझे
हाँ
फ्यूजिबल
हाँ।
प्लग का। ये क्या सीन है,
गाइस,
कैसे
वो फ्यूजिबल
मैकेनिज्म है?
प्लग जो होता है वो स्टीम ड्रम पे नहीं होता है, वो फर्नेस प्लेट पे होता है।
फर्नेस प्लेट पे होता है,
तो
इतना तो
जब
मुझे
भी,
पता है।
हाँ,
हम्म
तो जब पानी का लेवल नीचे चली जाता है,
हम्म
वो ऑब्वियसली वो जो फ्यूजिबल प्लग वाटर में था
हम्म
वो अभी बाहर हो जाएगा, और जो स्टीम के हाई टेम्परेचर की वजह से वो जब मेल्ट होगा,
हम्म
तो वो जो स्टीम है वो
हम्म।
स्टीम उसके अंदर जाएगा, जिसकी
स्टी
वजह से वो जो कंबशन हो रहा है,
जो फर्नेस है कंबशन हो रहा है,
हाँ हाँ, क्योंकि
उसको
वो
बुझा
बाहर तो
देगा,
रिलीज करेगा नहीं,
उसको बुझा देगा।
बुझा देगा,
या
और फ्यूल
स्टीम
सप्लाई
और
बंद हो
वाटर
जाएगा।
दोनों ही स्केप करेंगे उस होल से।
बुझा देगा। मैं इसको पढ़ूंगा। आई विल रीड ऑन दैट। ओके, रीड ऑन। ओके, उसके बाद इस पे मैं।
Shall I
यार ज्ञान,
try this one out?
ज्ञान मैंने जिसको पढ़ा था ना,
हम्म
उसमें ये था कि अगर वो फ्यूजिबल प्लग मेल्ट हो जाता है तो जो स्टीम है वाटर है उसी होल से वो स्केप कर जाएगा, तो वो फर्नेस में जाके उसको बुझा देगा।
अच्छा।
Yeah,
यस
guys.
एग्जैक्टली।
या हु इज दैट? प्रज्ञान।
Uh, yeah. Shall I try this one out?
या गो अहेड। It's a
Yeah,
democracy.
Yeah, sure.
a fusible plug is a last uh, is a boiler safety mounting,
Hmm.
and it consists of the following part: its main body, which is made of a higher melting point metal, and the internal fusible metal, which is brass, which is a low melting point metal, right? So when the fusible plug location is very important on the boiler. It is mounted on the crown plate of the boiler on the top. So whenever due to the excess temperature or the increased level of steam, sorry, I'm sorry for that. So when the water level drops
Hmm.
and the fusible plug tip comes in contact with the steam, it melts the fusible metal, and which makes way for the steam to go out to a predetermined location. And we use these in boiler and compressor, right? So in boilers it goes to the furnace directly, or we call it the firebox, where it extinguishes the flame which is running the boiler. And in the case of compressor, it's just the surroundings of the compressor.
Yeah, our question, our doubt was that when fusible plug melts, what happens after that? Does the high temperature steam get out from that
It
vessel
gets to the furnace.
and turn off the
The
furnace?
boiler is heating the water in the boiler, right?
Hmm.
The boiler is heating up the water, so it has to draw the heat from the furnace, right? We have to put on the gas to boil water, right?
Correct.
So the steam directly goes to the flame, which extinguishes it.
Okay.
It is a last
Uh,
safety device of last resort.
Oh, Herschel,
Harshal
yeah,
is showing something.
let me
Yeah.
pin Herschel. Okay,
Yeah. See the diagram.
Herschel, you are pinned.
Yeah. So here is the fusible plug exactly. You see, it is on the this furnace plate.
Fusible
See,
plug,
here is the combustion, and here is the fusible plug.
yeah, fusible plug. It is a steam drum. Oh
It
God.
is in the see. Here is the all water, and here you have the steam space.
Mm,
Here.
mm-hmm.
So whenever the water goes down,
uh,
this fusible plug will melt, and it will extinguish the fire.
oh, as simple as that.
Yeah.
But isn't water is the good source to extinguish fire instead of steam?
Water is a better method, but the location of the fusible plug is at the top of the boiler, right? And at the top of the boiler, we only have steam, not water.
Yeah.
Water is at the bottom of the boiler.
Okay. And anyway, because of low water situation, fusible plug is melting. There is no water enough. We are not having enough water in that situation.
On ships, we have to maintain a level of security, right? So
Uh-huh.
we do not allow the water level to go that down. The
Mm-hmm.
fusible plug self-activates itself at a safe water limit.
Mm-hmm.
I heard from someone that there is low water level shutdown.
Yeah,
Yeah, I've
it is
also
low
heard.
water level.
Don't say
It is water level for
Fusible plug.
performance level,
don't say
but not
both.
for the level of explosion.
See, so don't say both the things, low water level shutdown or fusible plug. Either say low level water shutdown, either say fusible plug.
Yeah,
Something I have
basically they have both they have the same function.
on board ship we have low water level shutdown, isn't?
Yeah. Yes.
We don't have fusible plug on the ship.
Yes,
No,
I
you will
heard
never
from
find
someone that
fusible
Yes,
plug on
we
board.
have.
we have. Checkpot, can you please tell
But in
us
the
what
Dreamers,
is the
Sir has
location for that?
specifically mentioned that there's no fusible plug on.
Future plug is a safety device. Alarms are different. Safety alarms are different. Safety devices are different.
Yeah, Jack is
Oh,
there.
okay.
Okay, yeah. Jack, we were
This
in
is straight.
doubt, on board ship, what we have, fusible plug or low water level shutdown?
Both.
Both?
Yeah. Fuel plug is a safety device, and low level water level is a safety alarm and trip.
It is trip now. Fusible plug is also a trip.
No, it's like safety to secure the boiler. Otherwise, boiler will run on low water, then develop and melts the metals. If too much heat there, water is not there, it will start to heat up the metal and start metal to melt.
Yeah, correct. Now moving with the next question, guys. Now, what are boiler
Yeah.
accessories? Yes, yes,
Okay.
Rakesh.
I have to leave.
Okay, Rakesh, I will be sending you
Art
the
of
meeting
Jana.
recording. Okay, and guys, be
Yeah,
with
sure.
remaining guys, be with the meeting. These are the possible questions that can be asked. If you are not knowing at all, we will be learning something. We are having Jack also. Okay.
Gyan,
Yes.
uh, I do also have to sleep. I have to go for the job in
Let
the
me
morning.
take.
Can you please
It's
also
it's 11
send me the
20.
recording?
Okay. Yeah. Okay, Pragyan ko. It was nice, yaar. Keep coming. Okay.
Yeah, it
Uh,
was very nice. I will join every day.
Okay, and I think Karthik has left already. Let's see who fight till the night. Okay, Pragyan, take care. Okay, so so guys, my next question is, what are boiler accessories? Okay, so who is going to answer? Harshal is there. Boiler. I am not asking about boiler mounting. I am asking about boiler accessories.
So basically, the boiler accessories are there to increase the efficiency of the boiler. So if I name the accessories, we have the air preheater, economizer, then we have heat pump, right? So all these are accessories.
Oh, air preheater economizer. I agreed. It digest. Heat pump? Are you sure?
Feed pump.
Feed pump. What is draught system? Is it not count in accessories?
It's like a efficient only. It's like a accessories only because it increases the combustion.
So draught system we will count in accessories or not? We will.
Yeah. Because it increases the
Okay.
efficiency of the boiler.
I have heard about three main efficiency: air preheater, economizer, and draught on
Superheater,
superheater also. Okay.
feed pump and injector.
Yeah, superheater.
Superheater, feed pump.
Economizer, air preheater.
Okay, starting with the assembly, like anyone having Harshal, you must be having diagram of that. Where is air preheater, where is superheater, where is economizer, where is draught? Are you having that diagram?
I have the exact diagrams of the accessories,
uh,
so I'll send that in the group. Right,
okay,
right away
please.
I'll send it.
Okay, please send. I will be sharing the screen and we will be discuss what is the function exactly, because I think you have explained well. Boiler accessories for the efficiency purpose, and boiler mounting are for safety purpose. Correct? Harvinder, anything to say?
Jan, can you repeat? What are you saying?
I was saying that the boiler accessories are fitted for the efficiency, to increase the efficiency of boiler, whereas
Yes,
boiler
right.
mountings are for the safety of boilers.
Safety of
We can speak
right,
in
right.
case of interview, no? Oh,
Boiler mountings, it's not about all about the safety.
all about no boiler. Okay, so uh, If no, it is all about safety, I think. Anything what we can add?
Yeah, I've taken the screenshot in my online classes, so it's that only. Yeah.
Okay, you are not having that picture where every where
Yeah, I'll find that. I have one boiler diagram. I'll see.
okay,
I'll
where
send.
actually starting it is like starting it starts with air preheater, then superheater, then economizer, then draught system. Is that chimney? Is that draught system? No, Jack, I have doubt on ship we have draught system or not.
Forced draft system. In ship, we are using forced draft system.
In forced draught we use fan.
Yeah, FD fan, forced draft fan.
And what about that chimney that is fitted lastly?
In ship, we have to use most of the heat. Okay, the exhaust will go to the superheater and air preheater. Everything they will use as much as possible. They use forced draft system from the exhaust gas only.
Yeah, there was some definition like this of drought. Please, anyone if resonates with me, please uh, also explain it. Like if the actually what drought system does now, it increases the pressure difference. Okay, drought is the pressure difference of that from atmosphere, the pressure of atmosphere and the pressure of the boiler. The more pressure difference, the more flow will take place
Flow
in.
will be there.
It is
Yeah,
something like this. That is the we are talking about that draft system. That forced draft fan is increasing that pressure only. That pressure difference.
yeah, might be.
Okay, so that draught system is also depend on the height of the chimney. Since we don't use that chimney, that tower, okay, on board ship, so it is not affecting the draught.
We are not using chimneys, bro. We are using like fans, blowers.
Okay. Since one of the factors on the height of tower,
It's
yes.
like a natural. If you are saying if you are using chimney means it will automatically naturally take the suction
Okay.
from the combustion. It will automatically go to the
Yeah, amazing.
outside.
Okay. Harshal, yes, you have shared. Let me present. No. Okay.
Yeah, so if you're talking about draft, there are three types of draft. No, the one is natural, second is induced, and third is forced one. So Jack is talking about, I guess, the induced draft or the forced one.
The drought in which what is it called? First
That's
tell
the
me.
natural draft. That's
Draft.
the natural draft you're talking about.
First, it
Yeah,
is called draft or drought. Draft or drought.
you can say draft.
It is draft, no? It's was also left. Okay. Now let me. Am I able to uh, present my screen?
Yeah, your
Okay.
screen is visible. Yeah,
Okay. Now starting with first we have superheater, then economizer, then air preheater, and three are the main accessories. We are also having feed water pump and drought system where is to chimney. That is the natural drought. Okay. Huh?
there won't be any
Yes,
chimney in
yes.
the Jack on the ship. Do we have natural draft or which type of draft we have?
Forced,
Induced or
forced
forced one?
draft. Forced.
Forced one. Okay.
Yeah.
So we'll have the fan on the suction side, right?
Mm,
From where the air is entering into the combustion chamber.
okay.
It uses the exhaust gas which is already combusted in the furnace. It uses that exhaust gas to run the blower.
Okay. Starting with the
All right,
superheater.
all right.
Okay. Okay.
It's like a turbocharger only,
Uh,
but
s-
not turbocharger.
superheater. You are saying Jack. Superheater.
Yeah, yeah, there will be a superheater, air preheater, and post stuff fan.
Okay. Starting with let's study this diagram. we are having boiler. From boiler the steam is coming out, the gases, flue gases also coming out, okay, and going on the superheater. From superheater it is going to two engine and two economizer. In economizer we have feed water pump, okay. That feed water pump is getting heated in economizer, and the heated water is going in boiler. Something like
Yes, yes, yes.
boiler has to give less heat, like then boiler do not has to
No,
give.
no, production time will be lesser if you preheat the
Oh,
Yeah,
generation.
okay. And then after economizer there is air preheater, okay. Air preheater is for that preheating. We are preheating water also and preheating air also.
Yeah,
yeah.
What is the purpose of preheating air?
if your air is too much moisture or colder, how will the furnace use it?
Okay. Ah, making sense. So this is like that only, na? Yeah, I wish Vito is not there, and he would have explained in a much better way what actually it is. Anyway, we got some overall idea, and we have also picture it. Economizer is a heat exchanger, looking like what?
Yes, it uses exhaust gas to heat the water
Okay,
from the engine.
it is air preheater. Okay, all right. So moving with the next question, I think guys, anyone has to. Harvinder has left meeting also. Moving with next question, we have reflection and refraction that has been asked. So Harshal, what would you have said if it has been asked to you? Because you are also having your interview now, so pre-practice is necessary. Harshal, are you there? You are muted, I think. Anyway, Jack, listen, na.
Yes, I am here.
Okay. Reflection is bouncing back of light, and refraction is bending of light. Reflection, there are two laws of reflection. The first law is that angle of incidence is will be equal to the angle of reflection, and the second law is that angle of incidence, angle of reflection, and normal will lie on the same plane. Okay, the law of refraction having works on the principle of Snell, Snell constant, that the sine I will be equal to sine R, that the if ray is going from denser to rarer medium, it will bend away from normal. If you're going from rarer to denser medium, it will bend towards normal, and that relation will be given by the Snell constant, that is the sine I, that is the sine incident angle will be equal to sine refracted angle. That will help me or not explaining that much thing?
Yeah, you explained well, but it will be not clear as much. You have to differentiate between you are saying both at the same time. You're
Hmm.
giving the answer both the answer at the same time. So interviewer is can understand. If you are not able to understand, he will not
Correct.
try to
So
give separate answers.
separate answer is reflection, bouncing back of light. There are two law of reflection. Angle of incident will be equal to angle of reflection, and the second law is angle of incidence, angle of reflection, and normal will lie on same plane. Okay, refraction is bending of light, and it is given by the Snell's law, that sine I is equal to sine R. When incident ray goes from denser medium to rarer medium, it will bend away from normal, and when it goes from rarer to denser, it bends towards normal. And that incident ray and refracted ray, already told you, that will be the related by Snell constant sine I equal to sine R. that much differentiation that I have this time told differentiately, like separately.
Yeah, yeah. It's much better than before. It's much better than before.
See, Jack, mostly time what happens now, if you don't practice before the interview thing, at the same time, we don't all of sudden we don't know how to explain the things, and we got clustered in our own explanation and get our confidence lose. So I don't want to this happen with me. Okay, so I am practicing a minute questions, okay, that can be asked. Now the next question is, Jack, thank you, you are with me because it is related to you also. Safety device of refrigeration system. So what I know about safety device of refrigeration for the time being is low pressure cutout, high pressure cutout, low lubal pressure alarm and trip, and I am doubt about bursting disc. Bursting disc is also present in refrigeration safety.
I never heard of it.
Okay, so I will be not speaking that busting this. I will be speaking rather low condenser pressure. In condenser, low level of condensation pressure. What was that? In condensation pressure, the pressure should be that much for that in condenser coil. Yeah, now Harshal has come. Okay, yeah, Harshal. From the last time I was calling you, you didn't.
Sorry, I just
Okay,
yeah, I was just went. So,
okay.
what was the question? This safeties of
Safeties of refrigeration system.
HP cutout, LP cutout, and low lubal pressure cutout.
And also there is one also that is called low condenser pressure alarm. It is alarm or trip.
Yeah, that's low pressure cutout. That's the same thing. If
Condense
when the
low
desired
pressure.
temperature,
Low pressure cutout is for low compressor na cool. Yeah, Jack, listen, is it same? Cooling water low pressure cutout in condenser. Cooling water low pressure cutout in condenser. Jack, is it like is there something cooling water low pressure cutout in condenser?
Never heard of it, bro.
Okay, all right. And oil separator can be called as a safety device. Oil separator is after compressor and before,
Compressor.
after compressor and before condenser, like at outlet of compressor, inlet of, before inlet of condenser. What happens, what it does, it separates lube oil, separates lubricating oil and give back again to the sump of the crankcase of that compressor to lubricate it. Okay, and the third one is the fifth one is oil heater. What it does, it maintains the temperature of lubrication in crankcase of compressor, because when there is a chances when the system turns off, system is not on, so there is a chances of mixing of refrigerant and the oil, so that's why it maintains the temperature not getting mixing. So oil heater is that only. Is, have you heard of this oil heater thing? Oil separator you must have heard, or
Yeah, yeah. I'll heat also we heard.
it is like that only.
Yeah, yeah, yeah.
Okay,
And
so
also you include the solenoid valve. It's like a stopping. When the compressor stop, it will stop the flow of the refrigerant in the system.
so HP cutout as LP cutout is same thing na, for,
No, HP is for high pressure, LP is for low pressure.
and solenoid is for when so when compressor stop, the flow of refrigerant also stops na. Yeah, Harshal, without raising hand you can speak. Okay, not much people.
just there was one more cross question.
Yes.
If someone asked what is the desirable property of refrigerant, so what would you answer?
Yeah, my answer would be, the first answer will be high latent of vaporization, low boiling point, low critical temperature, high freezing point, non-flammable, non-toxic, non-corrosive, low global warming potential, low ozone depletion potential. That much I will be
Include
speaking.
Yeah,
include the with it important to mix it with the oil, crankcase oil. I
miscibility
didn't
with the
get
oil.
miscible or
mixability.
I am not going into because into that thing because I am not very much sure, very sure that oil should be miscible or immiscible. If it is,
It should be mixable. It should be mixable
it will not.
because because if it's not mixable, it will goes with the refrigerant on the discharge side of the compressor.
Mm,
The oil won't be returned back if it's not mixable. It will stay down in the tubes itself and started fouling.
mm.
If it's miscible, it will come return back to the compressor.
Yeah, it should be miscible, no? Okay.
Yeah.
Yeah, and also there's low specific volume, low condensing
So
pressure.
if it low condensing pressure, low specific volume, yeah, I need to revise it again. All of a sudden, it is not coming. Low specific volume, low conden condensing pressure. Yeah. Okay. All right, guys. Next question is safety device of compressor. Yeah, Jack. Yeah.
No, no, I just appreciated your answer. You told the exact and more things of that.
Okay. Thank you. The next question is uh, safety device of compressor. What we know is low loop oil pressure, trip and alarm, bursting disc, okay, and
Fusible plug, relief valve.
fusible plug, relief valve, more called fusible plug, relief valve, low loop oil pressure tip, jacket water, high temperature alarm and trip, okay, bursting disc, motor overload trip. That motor overload trip and automatic unloader was the same thing. We have remember we had discussed the diagram
Can you come again? Water?
that there is. I have written one safety device of compressor is motor overload trip. Okay,
Yeah.
is it the same thing that is
No, unloader is different. Motor overloader is different. It's to prevent the motor overload.
an automatic unloader was after cooler
Working. No, no, it's working in the compressor only to reduce the stress of the compressor.
to reduce the stress? It can be called as safety device of compressor.
Mm, might be.
Might be.
Yes,
Whether not to say if he's not asking about. Yeah. The next question is four stroke versus two stroke. We have asked many times, discussed many times. But Harvinder, since Harvinder is new joining, I would pass to you this question. Please, Harvinder, say it. The four stroke and two stroke. If it has been asked to you, how do you say the answer?
so I will differentiate like in four stroke, we have one power stroke in four stroke, and for every two revolution of the crankshaft, we have one revolution of the camshaft. And for the two stroke, for every two stroke, we have one power stroke, and for every one revolution of the camshaft, we have one revolution of the crankshaft. So in case of four-stroke engine, we have valve and valve mechanism. In case of two-stroke engine, we have ports. And in four-stroke engine, the volumetric and the thermal efficiency is higher. So in case of four-stroke engine, the flywheel flywheel is heavier because of the non-uniform turning movement, right? So other differences in case of four-stroke engine, the
Go ahead.
Yeah, I think in four-stroke engine, in two-stroke engine, we have higher temperature and more lubrication is required inside the engine. Not the lubrication, cooling is required inside the engine because in every two stroke we have one power stroke. So more, temperature will be high inside the engine. In two stroke is used as a main engine and four stroke as the auxiliary engine.
On board stroke. Did he miss
So
any
you missed
point?
out on the main thing. Yeah, you missed out on the main thing, that is crank.
What?
You missed out on the most important thing, that is crankshaft to camshaft ratio.
Yeah, I mentioned it in the first at the first.
Didn't mention like that the crankshaft to crankshaft ratio. He mentioned like the power after every two power, like every two power stroke, every power
No,
stroke we have two
but
revolution of crankshaft. Okay, he okay. Okay, Harvinder, I have some cross question for you. Okay,
okay.
first tell me, in a case of, first tell me, okay, first tell me, I have muted Jack because there was so much noise from your side. Okay, for the time. Okay, so Harvinder, tell me that in a case of four stroke engine and two stroke engine, how camshaft and crankshaft connected?
So the camshaft is connected by the timing gear or the belt arrangement
In which stroke? Which type of stroke?
in four stroke.
Okay. Belt in four stroke it is connected with belt time. What gear or belt? What you said? I just missed out.
So, sorry, I'm not able to differentiate between the.
Harshal, you
Uh,
know answer. Like if it is asked that in
Yeah,
four stroke how camshaft and crankshaft connected, crankshaft and camshaft
yeah,
connected. Okay. Yeah.
yeah, I know that.
Okay.
So if I'm talking about the, see, I'm specifically talking about the ship. Okay.
Mm-hmm.
So as we know, the two-stroke engine have a larger stroke, right?
Mm-hmm.
So there will be so the distance between the crankshaft and crankshaft will be more. So we won't be adding any gears there because there will be a lot of transmission losses. So we have a chain and sprocket arrangement. So it is transmitted through the belt, right? And in case of the four-stroke engine, we know the compression ratio is less. So we have the gears. It is connected through the gear arrangement, and in between we have the timing gear, right?
Harshal, like why we use gear arrangement in a case of four stroke, there was one reason I have heard. I need some clarification by the jack. I am going to explain what I have heard. Since the camshaft and crankshaft don't revolve at the same speed, so
Correct.
gear is something that is used when there is a speed in difference. Kya jack, you
Yeah.
got me?
It's like a 1:2 ratio.
Huh.
Yeah.
So that's why we can't use belt drive for that.
The four-stroke engine. That's the reason there's a timing gear in between to time the this rotation of the camshaft and crankshaft.
Yeah, that is correct na, because I was in doubt. I need to clarify it because one of the other, okay, Harvinder has left. Okay, one of the other reason was that the in a case of just you told that in a case of two stroke engine there is long arrangement. Okay, and so that's why we need built-in sprocket. Okay, to reduce the dead weight and all, and it at the same time it has same speed. So at the case of pulley, same speed built is okay to use. So it can be one of the reason na, like it is main reason na, because in
Yeah.
a case four stroke, if it is asked like can we use built-in sprocket mechanism in a case of four stroke, the answer will be what, jack.
No, sir. If you use belt means the transmission will be equal, so no timing difference. You can use teeth difference with a belt. No chain. You can't use the belt.
Mm, correct. uh huh. Harvinder has left. There was another question. Harshal, you noticed that he mentioned we always say the thermal efficiency of four stroke is more. than the two stroke, because because of four stroke has better scavenging. Okay, that's why thermal efficiency is more. Okay, he said volume efficiency of four stroke will be also more than the two stroke. Is it correct? Volumetric efficiency.
Volume
Yeah, volumetric
volumetric efficiency.
hmm.
Uh, I'll have to see because if you see I think he's correct because in the two-stroke and four-stroke, the differentiation in the Dreamer's package is given that the volumetric efficiency of two-stroke is more than four-stroke. I guess
Let
it's
me check
given
on
like
the
that.
spot. Let
Yeah.
me check on the spot, because volumetric efficiency, when we talk about when we burn the fuel, okay, like in a case of petrol engine, diesel engine, Otto cycle has high volumetric efficiency.
Yeah, correct. The two-stroke engine has less efficiency, less volumetric efficiency because there's less time for scavenging. In four-stroke, it's more. It's like that.
Volumetric efficiency is क्या? Swept volume upon actual volume is something like
Yeah.
actual volume upon swept volume, or swept volume upon actual volume. The ratio is I am not knowing. Jack, what is that? Volumetric efficiency is the ratio. What is that? Volumetric efficiency formula, Let me search herself, because at the same point of time we have to clear our doubt. We don't have enough time to drag it on. Volumetric efficiency formula. Then we will. Oh shit, why net is not working? Let me search on volumetric efficiency represent the volumetric and formula. Volumetric efficiency is the ratio of the mass of air and fuel that is trapped by the cylinder during the induction divided by the mass that would occupy the. Okay, so what is that? Volumetric efficiency is ratio of actual volume, that volume, fuel air mixture upon swept volume. Swept volume, that is. Okay, so anyway swept volume is going to be more and actual volume. So one you were giving one reason that because it has don't the mixture, the fuel combustion is not happens that much properly, the air mixture ratio is not happens good in a case of two stroke, because so the volumetric efficiency, how he said, Harvinder said, how volumetric efficiency will be higher in two stroke.
because because when sir explained, it was like if see the sir has explained that we can't increase the rpm of the two stroke because there will be less scavenging time then. So sir has also mentioned that because of that there's less volumetric efficiency as well because we don't have proper time for scavenging and all.
Yeah, in a case of differentiation he didn't uh, like I am reading out, there is no relation of volumetric efficiency, but I am going to search volumetric
Yeah,
efficiency
even
up.
I'll do that.
Okay, because it is really needed to, and since every time we discuss, we should have also discussed this perspective volume. And thanks to Harvinder, he came and left with the question. Okay. Okay, of two stroke and four stroke stroke and four stroke comparison. Two stroke is more efficient than four stroke because it produces more power in one revolution, which has more volumetric efficiency compared to four stroke engine. Two strokes are lighter, more efficient, having the ability to use lower grade fuel and more cost efficient. Therefore, the lighter engine results in higher power to weight ratio. अरे यार, it is not showing. Why is volumetric efficiency is higher in four-stroke engine compared to that in four-stroke engine? The overall efficiency of four-stroke engine is high as majority of. You got any satisfactory answer from your side, Harshal? No, it's okay. Harshal, are you there?
Yeah, yeah. Even I'm searching.
Two-stroke tend to have higher volumetric efficiency than four-stroke engine due to their simpler design and lack of intake and exhaust valve mechanism. In a two-stroke engine, the intake and exhaust process occurs simultaneously, and fresh air and fuel mixture is drawn into the engine on every cycle. This result in higher scavenging efficiency and more complete filling of the combustion. More complete filling of the combustion is can be the reason, because the better scavenging takes place in a case of four stroke. Okay.
Yeah.
Yeah, since two stroke is a long stroke, two stroke engines are long stroke engine now.
See, it is mentioned, bro, in the two-stroke versus four-stroke in Dreamers. In two-stroke, it is mentioned that less volumetric efficiency, poor scavenging, hence less efficient. And in four-stroke, more volumetric efficiency, more efficient. It is clearly mentioned.
I will read it again. Na?
Yeah, yeah.
Doubt volumetric efficiency. Thanks to Harvinder.
I've told you that it's because of the poor scavenging. That's the reason.
Yeah,
Because then
poor scavenging is the reason for thermal efficiency. See, go by the formula. Volumetric efficiency is what? Nothing has to related with the combustion or something. It is just the ratio of the actual volume of air mixture fuel inside cylinder and the swept volume. If the swept volume is this of cylinder and actual volume is this, in a case of two stroke, and in a case of four stroke, suppose swept volume is this and the actual volume is this only, then the volumetric efficiency of two stroke will be more, because it has higher cylinder, like it uses longer cylinder. uh, I will revert to with this answer of this question. Okay, but it has nothing to relation with it has only to relate with the amount of fuel that is burning inside the amount of mixture that is burning inside the combustion chamber. The more amount of mixture that is burning inside the combustion, more is volumetric less efficiency. Anyway, the more when there will be more people, we will be discussing that. Before that, I will search by myself, because there are some contradicting answer I am also getting on internet. Okay, Harsha. So any other doubt regarding this?
I think we should, we should discuss with this volumetric efficiency with everyone when there are more
Yes,
people,
also, and
because it is
yeah,
very contradicting.
yes.
Like it's in the Dreamers package given less volumetric efficiency. Now it's a doubt.
Okay.
If I say it in the interview, what will I answer then if he
Yeah.
cross questions me?
Before that, only we have to figure out. And Harshal, on this Sunday, Arvind sir is going to take a meeting again. We will ask to him also. Okay.
Yeah, yeah.
Okay, guys, it's
Can when
uh,
is your semester 8 exam? Is it coming or
it's after 15 days. Who cares? I
even? Yeah, even I've started studying because I have my exam in next 8
in
days.
this semester I didn't even gone for single day on my college, didn't. And before 1 hour only I have given mid sem, and I have prepared, and I got a 20 plus mark out of 25. And so, and
Nice.
teacher knows me well, so in case of debate I will just go and lie down on their legs. Try, mom. Okay. So that is.
Have you applied for Samundra?
No, yaar, I have to. I was waiting for Anglo interview. What is the last date, by the way?
It is as searched. There's no mention in the form. It's just that it's for the September batch.
Okay, Samudra is way better than the Great Eastern. So,
According to me, because see, when the Pranit sir has made that video of comparison of the colleges,
mm,
so he has clearly mentioned that the scenario will change, and that video was way back in I guess in 2021. And
mm,
the end, he made that video.
mm,
Now the scenarios change. If you see for the engine cadets,
mm,
this waiting period is very less in
mm,
Samundra.
mm,
And also, if you see in Great Eastern, it's the Indian company, and in Samundra, you are getting into multinational company. It's executing executive shipping management,
mm.
and it also has more ships than Great Eastern. It's
Yeah, yeah,
150
I
plus.
have to apply that also. I can't take risk. Yeah. After
And
all.
also, if you see,
Uh,
it's because of ESM. There's less ship, but if you see the campus of Samundra, it's one of the best. Not one of the best. It is the best campus in the Asia. If you
yeah,
see for
yeah,
maritime,
Samudra.
because
I have also heard about that. That, uh,
even
yeah.
Pranit sir has agreed to it
Mm, I have heard that
because
session
it has
about.
LNG simulator
Mm,
inside the campus.
mm. Better to I hope to get selected in Anglo. Otherwise, I will try in Samudra. Otherwise, in I may
Yeah,
go. Yeah, I have I missed the chance of getting synergy because I am not prepared for that. And the thing which I am not prepared for, that is very rarely that I get into that. Let's see, because I have given
synergy.
time for interview for Anglo. Let's see what happens. Yeah, don't know what the result can. What?
You will get past if you answer properly. It's not what I've seen is the questions are very repeated that we are practicing, and now I'm very bored of it. Like practicing the same
Yeah,
questions
see,
and
see,
questions.
see, that is the reason, and that's why, that's why many people left me. Like Kiran, Hipajat, everyone. In starting, they were so brilliant people. We were starting with, and now we are having 130 people in the group now. That has been started by the four people only. Okay, there we used to discuss a lot. Looking every time our mind is very much kind of boredom, but I didn't give up. That I will discuss thousand times, and I will create a confusion. I will dig out the any other scenario that can come out of that. Okay. So
Yeah,
because see the
even I've seen many people have left this
yeah,
because they are frustrated now
yeah.
because of the waiting and all.
Yeah, many of my good friends, they taught me. Now I'm speaking somewhat very better, very frequently. They taught me. One guy was saying about Ejaz brother, na, that you have
Yeah,
improved Gyan. I was very glad to hearing that. These were the people in the initial phase told me, taught me to how to speak, caught my errors and all. So I'm not
yeah,
going to forget all of them. But what they now I don't have their support as well. Okay,
yeah,
so
correct.
things will go on like this only. If I'm not getting selected in Anglo now, I can't give on, and I can't be bored. See the condition of teachers who are teaching same day every day, everything, every
Yeah,
day same thing. Okay,
yeah.
now I am
Uh,
understanding, we are understanding what kind of harassment is this.
you know what I've understand one thing, that it is also a matter of luck in the interview sometimes.
Yes, Harshal, that's fine. I'm
because
also fearing that
because one
my.
of my friend who got selected in Samundra, no,
Mm,
I've asked him the questions.
mm,
I've told you, no, he's passed out from Samundra.
mm,
So I asked him the question. It was very basic questions, bro. That
mm,
interviewer asked him,
mm,
tell me. He didn't answer any of the non-technical question. He just answered the technical questions, and he got selected. He said, "I
mm,
don't know, sir." Then
mm,
he asked, "What are the seven oceans? Just name it." He only named three oceans. That's
By the
all.
way, there are only 5 oceans, bro. Okay.
No, sorry, the continents and then the
Continents.
oceans.
5 oceans,
Yeah,
7 continents.
7 continents and the oceans, 5 oceans. He
When I
only
was in
answered
my
three.
nursery, I was knowing that these things. Okay. Uh, See, yeah, that's fine. After yeah, we had very good guys, Harshit, Kamlesh. They were
Yeah.
fantastic, yeah. When they got rejected, it really hurted. Okay, and
Yeah.
at the same time, we almost lost hope. But let's see what happens. जो लिखा है कुदरत का उसे कौन मिटाएगा. मैंने 4 साल दिया. मुझे नहीं पता था कि चीफ इंजीनियर प्रिंस सर के मतलब प्रिंस सर मुझे पर्सनली गाइडेंस करेंगे, गाइड करेंगे मेरी
Mhm.
मतलब. वी गॉट 3 साल पहले से मैं तीन
Yeah.
साल से जुड़ा हुआ हूँ. बहुत कुछ सीखा, बहुत कुछ सीखा. काम किया. मैं सही से बोल नहीं पाता था, हमेशा इंग्लिश में बात करने की कोशिश किया. तो धीरे धीरे मैंने चीज़ें बहुत सीखी लाइफ में. और ऐसा किस लिए
Mhm.
हुआ अब पता है. हर्षल, वन स्टोरी आई वांट टू टेल यू. मैथ आई गॉट 1 number less. At that time, I was aware about the Anglo criteria that was 60%, 60 plus, and I got 59 number in math. I cried a hell in a case of intermediate कि 1 नंबर मेरा कम हो गया. इतना मेहनत मेहनत किया. इट आई गॉट. सो व्हाट आई डिड. Without telling anyone in the home, I felt improvement. Without having that much of money, I went to Allahabad, the center for exam. I slept all day with the open roof near the Sangam Nadi in Allahabad, on the sand nearby the. And with the I ठंड का समय, तो उस समय मैंने जो कूड़ा होता है कूड़े बिन के उसको जला के एक साल लिया. तो सॉल लेके जो है अगले दिन पेपर दिया. एक दिन पहले पहुंचा. 100 रुपया में 4 पूड़ी खाई थी. कुंभ का समय चल रहा था. वो 2 पूड़ी और वापस आया. मैं 2 दिन में सूख गया था आके. एंड दैट टाइम जब मैंने दोबारा पेपर दिया ना, 71 नंबर आया मेरा. अगर सपोज हर्षल वो 61 भी आ जाता ना, तब तो मैं खुश हो जाता.
Mhm.
लेकिन भगवान ने ऐसा किया कि मुझे 65 से ज्यादा आ गया मेरा. ठीक है, ताकि मैं एलिजिबल बन गया आज एंग्लो के लिए. सो लेट्स सी यार, अब ऐसा क्यों हुआ था. डॉट्स कनेक्टेड
हो
होते हैं मेरे.
जाएगा.
हम्म.
ऐसा है कि इवन आई हैव सीन लाइक मेरा मेरा बैकग्राउंड ही नेवी से है. ठीक है, मैं मेरे डैड भी नेवी में थे.
हम्म.
एंड ये थोड़ा पहले से ही है कि मर्चेंट नेवी ज्वाइन करना है. बट इन द इनिशियल स्टेज आई वाज लाइक नहीं, मैं कंप्यूटर में जाता हूँ, सीएस करूंगा. लेकिन वो मेरे को ब्रांच मिला ही नहीं, मेरे को मैकेनिकली मिला और मैं मैकेनिकली कर रहा हूँ. तो
हम्म.
इट्स लाइक कि भाई घूम फिर के आए वहीं पे जा, जो करना है
हम्म.
वो हो ही जाएगा एट द एंड.
यार आई विश यार जैक का भी हो जाए. जैक इज देयर बिकॉज ही इज ऑल्सो एस्पायरिंग फॉर. ठीक है. जैक सो गया क्या.
He's from Marine, right?
हाँ, ही इज फ्रॉम मरीन. ही हेल्प अस लॉट. ओके.
Yeah,
ठीक है हर्षल, इट वाज नाइस यार. it almost 12, and nowadays I am asking for guys to run a marathon to just a large number of question we discuss in one meeting, because now
yeah.
we should level up. But after that, only you left. Okay. And anyways, crowd at the bottom, not at top. Remember this. Okay.
Yeah.
Uh, okay. Bye Harshal, thanks. Bye Jack.
Yeah, bye, bro.
Oh, bye. Take care guys. Bye, good night.
Yeah,
Good night.
yeah. Bye.